Welcome to this week's episode of Basics of Programming. This inaugural episode will be an introduction to writing and compiling code, and the series as a whole will be intended first of all as an introduction to programming for those new to the subject. As with future episodes, there will be two sections to this video, a section on essential knowledge on the subject, and later a section with additional information. The timestamp for the latter section will be in the description for those who want to skip directly to it. With that out of the way, let's begin. Part 1. Essential knowledge about writing programs. With increasingly complicated code and increasing mainstream popularity, programs have been portrayed somewhat unclearly. So what is a program? At a fundamental level, a program is simply a set of specific instructions for a computer to follow. However, unlike a person, a computer is physically unable to deviate from its instructions. So programming is the science of making a computer follow a specific and consistent set of actions in order to achieve a goal. However, many applications of programming need to be extremely versatile. For example, think about how many different actions can happen in even a small portion or a single moment of a modern video game. In each possible case, the program must act predictably and efficiently. This number is impossibly large, and it's unthinkable to consider checking for each case, as even if you could program each case individually, the time it would take to sort through them and figure out which to pick is way too large to run a game on. In this case and many others, one of the primary aspects of a good program is being able to work as intended under many different cases. Though we are not tackling that topic today, know that a large portion of the tools given to you are dedicated to allowing for greater versatility. However, understanding what a program is does not allow you to write one. So how do you write a program? Programs are often written using programming languages, which are a set of instructions and keywords specific to the language that a person can understand. Programming languages are named such because each has its own words, often its own dialects, such as C++ and C# being built off of C, and its own quirks. Anything you can write in one language should be writable in most other languages, similar to spoken language. But most programming languages have unique advantages over the others. Some examples of popular languages are Java, C, Python, and C++. Most programming languages are compiled from left to right, then top to bottom, similar to reading in English. However, some actions will be prioritized over others, similar to the order of operations in math or PEMDAS. At a basic level, this priority will be most important when using parentheses or math operations. Most languages will have similar, and often even identical, commands, but how we write these commands varies from language to language. How languages determine how to interpret code is called syntax, and it can be thought of as the grammar of a programming language. If you look at the image on the right, you can see a program written in Java that, when run, outputs the words "Hello World." Words like public and class are keywords that the language always interprets identically, while the following word, "Hello World," is simply the name of the class that we can change as we wish. Later, we can see the words system.out.println, in which the program understands as instructions to output the words inside the parentheses. In this case, you can see how these words act predictably as a language. Now we move on to part 2, additional information about compiling code. This section will be more in-depth than the previous and is not entirely necessary to program. Feel free to drop out here if you need the time to digest the information presented previously. First, let's talk about the various levels of programming languages. Since computers read instructions in binary language, which is a series of ones and zeros, humans can't understand or program at this level, and instead program using high-level languages. The main exception to this is assembly, which is the lowest level language people can understand. Most high-level languages are either compiled directly into machine language, which is another term for binary, or first into assembly and later into binary. High-level languages are compiled into low-level languages automatically. As a result, you do not need to know or program in low-level languages. The image to the right shows the hierarchy of languages, and for the most part, it's best to program in a high-level, or green in this image, language. This course will focus on Java, as it is fairly common and I am most comfortable with Java. Though I'll be covering topics common to most or all high-level languages, my examples will be in Java, and I will likely skip some topics such as pointers that are not relevant to the language. Now that we know how instructions are converted into a form a computer can understand, how are those instructions actually applied to the hardware? Instructions are given in binary and are quite literally a series of ones and zeros telling the computer which switches to turn on and which to turn off. Computers are built with an incredible number of tiny electrical switches, and computers turn those switches on and off according to instructions. As a brief aside, the reason computers used to take up entire rooms was because switches used to be much larger. A number of switches needed to just perform calculations required an entire room's worth of space. In the image to the right, you can see how switches can represent numbers in binary, as well as representing many other types of information, depending on how the computer interprets those switches. Here, an empty box stands for off, or 0, and a dark box stands for on, or 1. Programs are centered around memory and memory manipulation. Memory is a set of switches dedicated to holding specific information, and programs most often deal with setting and getting values from specific spots in memory. In particular, specific sections of memory are allocated to programs when they are run, and locations in that broader section are allocated to holding certain values that a program uses. This sounds, and is, fairly complicated, but in many high-level languages, memory is managed automatically, with others providing easy ways to manage memory such as pointers in C and C++. In addition, the vast majority of high-level languages allow memory addresses to be saved and stored in variables, which allow you to assign a certain memory address to a name, and then set and get values from the memory assigned to that name. Variables are extremely important in high-level programming, key to allowing complicated programs to be readable, and will be the focus of next week's episode. And with that, today's episode comes to an end. Feel free to leave comments below. I would love to see what you thought about the episode or any feedback on the format. And if you have any topics you would like to learn, please let me know below. Thank you for watching, and I hope you learned what you hoped to.